Good afternoon, guys. Today we're going to do the last lesson in set theory, and we're going to look at situations that can be represented with a Venn diagram with three circles in it. Okay, so we're going to have three intersecting sets. So the first thing that we're going to do is we're just going to use this Venn diagram here that has, oops, I changed my pen. This diagram here that has the three circles in it, okay, and it has all the parts labeled, and we're going to talk about sort of what each of the parts means, as well as what the set notation is that goes along with that. So just a couple things. So what each part of the circle, what each part means. Oh, whoops, that was okay. Let's see, my hands don't seem to be too steady this morning, so the writing isn't too good. Okay, so let's start kind of simple. And then we'll just sort of start with each individual set, right? Like, so we have circle A. So if we wanted to know all the elements in set A, that would be, and I'm not really treating these as if these are numbers, or if these are members of the set. So I'm not going to use the number notation. I'm just going to use regular set notation. So to find all of the elements that are in D, or that are in A, you would add D plus E plus G plus H. That's everything that's in the A circle, right? D, E, G, H. To find everything that's in B, or to list everything that's in B, that would be F. So F plus I plus H plus E, and then everything that is in set C is everything in circle C. So that's J plus G plus H. Let me just fix those. Plus H plus I. Okay, so then that should be an I. Something's going on with my pen, it's just not working as well as I want it to. So that's everything that's in that circle. Now if we wanted to do some exclusionary stuff, okay, so this is where the set notation gets a little bit trickier. Actually, I'll start from the center and work my way out is what I'm going to do here. So I'm going to go back to that. Okay. So if I want to just look at what's in H, so for the first part here, I listed what the set was and everything that's in it. I'm going to kind of switch things a little bit, and I'm going to list the letter and how that can be represented. So the letter H. Okay. The letter H is right in our very center, so that represents everything that is in A and B and C. Right? What that is the intersection of all three sets. Oh, the pen is just annoying. Okay. All right. Okay. Then what you have in. Okay, so just trying to see this. Okay, so that's H. So that one's pretty straightforward. If we move out a little bit, and let's just look at E plus H. So E plus H. So E plus H is the intersection of B, but it doesn't include, or of A and B, but it doesn't include C. So we'd write that as A and B and not C. Just like we could write, so for G and H, that's going to be A and C, but not B. Okay. And I and H would be A and, sorry, no, it would not be. Okay, so what was that? It was I and H. Will be B and C, but not A. That's how you'd write that notation. Okay. So these, what those ones show you, generally, is the intersection of 2 out of 3 sets. Okay, okay, so that takes care of that. Now you can also have just, so we had, like, we did section H, which was the intersection of all 3. We did G and H, which was the intersection of A and B, or sorry, A and C. H and I is the intersection of B and C without the other one, and E and H is the intersection of A and B without C. We can also look at just set part E, part G, and part I, and what that would say. Okay, so E wait a minute. Ha ha ha. I did this wrong up here, this top part here. Okay, so let's go back up to here. E, part E is just the intersection of A and B and not C. So we're going to erase this. So that's not E plus H. Okay. G is just the intersection of A and C without B. And I is the intersection of B and C without A. There we go. That makes a little bit more sense. All right. Okay, so E plus H is actually would be written as the wow, this pen's terrible. Okay. E plus H is actually the intersection of A and B. Okay, it doesn't exclude C. Okay, so we can include C, which then means that H and I would equal the intersection H and I is the intersection of B and C, does not exclude A, and G plus H would equal the intersection of A and C without excluding B. Okay, there we go. A lot of these become easier to understand when you actually have elements in them. They're a little bit, the notation can sometimes be a bit problematic when there isn't an actual element in there. Okay, now what we want to look at is just, we did E, we did G, we did I, we did G and H, we did E and H, we did H and I. So now what we want to look at is just D. So D, J, and F. So really what D is the stuff that's just in A and that's not in B and not in C. J is the stuff that's just in C and not in A and not in B. And F is the stuff that's just in B and not in A and not in C. Some other stuff that we can say. So we've been dealing with just intersections here, so it's always and, but we also have like the ors, right? So A or B or C is equal to everything. So that is going to be E plus F plus D plus H plus G plus I plus J. Okay, or you could do any combination of that. So that's everything. Right? You can also do A or B, A or C, or B or C. Okay. So A and B would be D plus E plus F plus G plus H plus I. A and C is everything except F, right? So D plus E plus G plus H plus I plus J. And B and C is everything but D. So E plus G plus H plus I plus J plus F. Okay, and so that's just some notation to kind of pay attention to, and you're more likely to get questions like this with the notation with the portion shaded, and you have to kind of pick out what it is that it says. So now let's actually do some examples. Hopefully my pen will work a little bit better than it has been working. We have a Venn diagram here that displays the results of a survey of 100 students in a high school regarding movies they watched in the last 2 weeks. We have three sets. Set P represents the number of students who watch Perfect Chill. Set C represents the number of students who watch Chill. And set D represents the number, Perfect Rebel, not Perfect Chill. And set D represents the number who watch Dazed. Okay. So we just want to pick out how many students in each section. So how many students watched only Perfect Rebel? So only Perfect Rebel is the 3. Okay, so 3 students watched only Perfect Rebel. Okay, that only is important. How many students watched Perfect Rebel? Well, that's everything in the P circle. So that's the number in set P, which is 1 plus 6 plus 1 plus 3. So 14. So if we were going to put this first one in set notation, it would be the number who watched P and not D and not C. That's how you'd write that. So try and do the set notation for each of these. Okay. How many students watched Chill and Dazed? So Chill and Dazed is everything that shows up in both the Chill and the Dazed. So that one right there. 1 and 6, because, whoops, nope, that's not quite right. Chill and Dazed, sorry, this one down here, that's what I'm after. Okay, 6 and 2. Okay, so that's the number who watched Chill and Dazed. So that's 6 plus 2. Fun that I write 2 and then I say 2 and then I write 8. So 6 plus 2 equals 8. Okay. Chill or dazed. Okay, so that's a little different now. That's the union. Part C was the intersection, so chill or dazed. So that's everything in the C circle and everything in the D circle. Okay. So that means everything in this little shape here, C or D. Okay. So that's 1 plus 6 plus 1 plus 66 plus 2 plus 17, which is 95, right? 8, 9, 10, 76, 86, yeah. So 8, 9, 10, 7, 68. There we go, 95. Okay. How many students watched all 3 films? So that would be the number who watched Chill and Dazed and Perfect Rebel. So that's just the number in the middle. That's 6. Okay. The number 2 outside the circle represents students who watched none of the movies. So you could say that as N, A, it's not A, not P, and not C, and not D. Okay. And the number 2 inside the circle, so that's this 2 down here, okay, that represents the number who watched Chill and Dazed, but not Perfect Rebel. That's where that 2 comes from. Okay, so there's one example, one question we can do. Okay, we're going to take another look at another one. We're going to kind of do an investigation. We're going to build a free body diagram from that investigation. So Rachel surveyed grade 12 students about how they communicated with friends over the previous weekend. 66 called on a cell phone, 76 texted, and 34 used a social networking site. Okay, and we're going to use set C for cell phone, set T for texted, and set S for social networking site. 56 called on a cell phone and texted. 18% called on a cell phone and used a social networking site. 19 texted and used a social networking site. And 12% used all 3 forms of communication. So these 3 in here, it's important to note that these don't exclude the third one. Okay? So for each of those 3, when we put them in, we're going to have to take off the middle amount. So here's a Venn diagram, okay? And we're just going to answer questions about it. So what does the universal set U represent in this situation? And the universal set U is all the students surveyed. So the grade 12 students surveyed. Okay. Percentage of students, record the percentage of students who used all 3 forms of communication on the diagram. So that is 12. That goes in the middle. Okay, and so we've used this one here. We've done this one. Okay. So we'll go on to the next page here. Determine the percentage of students who texted and used a social networking site but did not call on a cell phone. Okay, so this is the number who texted and social networking site but not cell phone. Okay. So then we had 19% texted and used a social networking site. So that includes the people who used the cell phone. And since there were 12% who used all three, we're going to go 19 minus 12, and that's going to give us 7. So 7%. So then we can put that in our diagram, that's 7%. So we texted and used a social networking site. So T and S but not C. So this is 7 that goes in there. Determine the percentage of students who called on a cell phone and used a social networking site but did not text. So same thing as before. We want cell phone and social networking but not texting. So cell phone and social networking is 18 minus 7. That looks nice. So that equals 11. Okay. And the number of students who called on a cell phone and texted but did not use a social networking site. Cell phone and texted and no social networking site. Okay, and we have that 56 called on a cell phone and texted. So 56% minus 12% will give me 44%. Stupid pen, okay. So we can put that on our Venn diagram in the appropriate places. So we have did I do something wrong there? Yes, 11 minus 7, 18 minus 12 I want, not 7. 18 minus 12. Let's fix that. And that's 44, not 49. Let's just remember that. Okay, so 6 is for cell phone and social networking site, and 44 is for cell phone and texting. Now what we want to do is determine the percentage of students who only used one form and update the diagram. Okay, so how we could write that with set notation is we want the number who texted but didn't use a cell phone and didn't social network. We want the number who cell phoned and didn't text and didn't social network. And we want the number who social networked but didn't cell phone and didn't text. So basically what we have to do is we look at the total who's, we have the total number who did each. So 66 called on a cell phone. So I'm going to do 66 here on the cell phone. I'm just going in order that it's on there. So 66 called on a cell phone, but we have to subtract off everything that is in the other part of the cell phone circle, right? So we have to take off the 6, the 12, and the 44. So 66 minus 6 minus 12 minus 44. Again, that's a 44, not a 49. So then that gives us 4 is left, right? So 66 minus 6 is 60, minus 12 is 48, minus 44 is 4. Okay. The number who texted, we start with 76, and then we're going to subtract off. For texted, we're taking off 44, minus 12, minus 7. and that leaves us with 13, it looks like. 32, 20 minus 7, yep, that's right. And social networked, we have 34 social networked, and we're going to subtract off 6, 12, and 7. So 6 minus 12 minus 7. So we're taking off 25, which is going to leave us with 9. Okay, and then we can fill that in the appropriate spot here. So we have 4 only used a cell phone, 13 only texted, and 9 only social networked. Okay. So the percentage of students who used at least one of these 3 forms of communication would just be all of the numbers added together, right? That's what we're trying to answer here. What percentage of students used at least one of these 3 forms of communication? So we're just adding up all of our numbers together. That's our last one here. So the percentage that used a cell phone, social networking, or a cell phone, or texted, is all the numbers added together. So 4 plus 44 plus 13 plus 12 plus 6 plus 7 plus 9, which will give us 95%, right? Which also means then that we can add in 5 on the outside. 5 did nothing. Those poor 5 people who have no forms of communication other than talking. Okay, how would your Venn diagram change if 16% of the students have used all 3 forms of communication? So we're going to add 4 to our middle number, so this becomes 16. So that means each of these numbers drops down by 4. So this would be 40. This is going to be 2. And this is going to be 3. And then the outside numbers, because we took 4 off of both of these, actually the outside numbers need to each go up by 4 to still add up to the same. So we have 8, 17, 13, and 5. Should be the same, right? Because 16 and 16 is 32, 33, 34, 42, 82, 92. Oops, no, the 5 isn't right. Sorry. Let's undo the 5 at the end here. 2, 2, 2, 3, 16, 48, 9. Okay. Where this is cell phone, texting, and social networking site. Okay. Okay. All right. So we'll keep going here. Okay, so we're going to use the following clues to answer the questions below. We're just again filling in the diagram, just filling in the Venn diagram. Okay. Okay, so we have 28 children have a dog, a cat, or a bird. Okay, so that means everything in here has to add up to 25. 13 children have a dog. So let's make our Venn diagrams: dog, cat, and bird. Okay, so this is everything that's in D. So that's the number in circle D. 13 children have a dog. 13 children have a cat. 13 children have a bird. Right, okay. 4 children have only a dog and a cat. 3 children have only a dog and a bird. And 2 children have only a cat and a bird. No child has 2 of each type of pet. So nobody has 2 birds, 2 cats, or 2 dogs. So we want to know how many children have all 3 and how many have only 1. Okay, so we always want to start with the middle, right? And the middle one we don't know. That's what we're actually trying to figure out. We're trying to solve for the middle. So I'm going to put an X in there. Okay. Then I'm going to fill in what we can out of this. All right, so we have that 4 have only a dog and a cat. So 4 have a dog and a cat. Okay, and that only a dog and a cat, so that excludes birds. Okay, 3 have only a dog and a bird, so that excludes cats, and 2 have only a cat and a bird, which excludes dogs. So those are nice to kind of figure out there. Okay, and then so we've put these 3 on there, and now what we have to do is figure out an expression for these to fit them in the hole, and figure out what's going on here. We have that 13 have a dog, so that means that 3 plus 4 plus x plus whatever number's in here is going to give us 13. Okay, so then what we want is 13 minus 3 minus 4, 13 minus 3 minus 4 minus x. So really what we have there is 8 minus x, right? 13 minus 3, 6 minus x. Okay, yeah. 6 minus x. Okay, is what's going to go in there. For cats, we have 13 have a cat. Okay, so 13 have a cat, but we have to minus off 4, minus off 2, minus off x. So 13 minus 4 minus 2 minus x. I'm just not going to bother fixing that. So 13 minus 4 is 9, minus 2 is 7. So this is 7 minus x for cats. Okay, 7 minus x for cats. And for birds, we've got 13 minus 3 minus 2 minus x. So that's 8 minus x. Okay. Okay. Now what we have to do is solve for x. That's what we're doing here, solving for x. So we know that all these numbers added together should give us 28, because 28 have a dog, a cat, or a bird, right? Since the number that have a dog or a cat or a bird equals 28, then that means that all these numbers added together need to equal 28. Okay, so 6 minus 4, let's try this again. 6 minus x plus 4 plus 7 minus x plus 3 plus x plus 2 plus 8 minus x equals 28. Okay, and we want to solve for x there. Okay, so 6 and 4 is 10, and 7 is 17, plus 3 is 20, plus 2 is 22, plus 8 is 28. Did I forget something there? I got 4, 3, 2, 6 minus x, 7 minus x, 8 minus x. 6 and 4 is 10, 17, 18, 19, 20, 20, 22, 30. 30. Negative x minus x is negative 2x, plus x is negative x, minus x is negative 2x. So 30 minus 2x equals 28. Negative 2x equals negative 2. X equals 1. Okay, so what that means is the number who have all 3 pets, the number that have a dog and a cat and a bird, is just 1. Okay. And then the number who have, we want how many children have only 1 pet. Okay, so we have to add that up. So this is going to be 7, 6, and 5. So the number who have only 1 pet is 5 plus 6 is 11, so that's 18. And there's a your turn question if you want to do this on here, and I'll just give you the answers so you can try it. The answer to the first part would be 3. The answer to the second part would be 12. Okay. And I think, even though I've got one more example on here, that's let's actually try this last example. We'll try this one here. Just my pen's driving me nuts, so I'm kind of annoyed. Okay, so we have Shannon's High School starts a campaign to encourage students to use green transportation for traveling to and from school. At the end of the first semester, Shannon's class surveys the 750 students in the school to see if the campaign is working. They obtain these results. 370 students use public transit, 100 students cycle and use public transit, 80 students walk and use public transit, 35 students walk and cycle, 20 students walk, cycle, and use public transit, 445 students cycle or use public transit, and 265 students walk or cycle. And so we want to know how many students use green transportation for traveling to and from school. So if we made our sets, we've got public transit, cycle, and walk. So we want the number who use any form of that. So who use public transit, or who cycle, or who walk. That's what we're looking for. So we want to add up everything in the circles. So this is a kind of question where we have a solution and we have to figure out where the error is. And so a lot of times with a question like this, it's just easier to just do your own. Okay. So as opposed to looking at the solution, we're gonna do our own Venn diagram here, and then we're gonna go back to the solution. Actually gonna cheat here. Okay. Circle. Okay. Circle, and it doesn't need to be quite that big. Okay. Okay. Look at that. I can make a pretty neat Venn diagram when I set my mind to it. Okay, so we had public transit, cycle, and walk. Okay, and so now we just want to add everything in here that we can. So we had 20 use all three. 20 students walk, cycle, and use public transit. So that goes in the middle. Okay, so we've done that one. Okay. Actually, maybe I should just check it as opposed to crossing it off. Okay, so we've used that one. Okay, so we have 370 students use public transit. So that's everything that goes in the public transit circle. So we can't do that yet. 100 students cycle and use public transit. So 100 cycle and use public transit. Okay, so that includes that 20 there. So we're going to put 80 in here because that was 100 that have to add up into that cycle and public transit. Okay, so that gets that one done. 35 students walk and cycle. So again, same thing. 20 plus what will give us 35. So that's got to be 15, right? Because that cycle and walk has to be 35. 100, sorry, I did the 100 students cycle and use public transit. Now we have walk and use public transit. That should be 80. I'd already checked that off. So this one here has got to be 60. Yeah. So that works out nice. So 370 students use public transit. So this number in here has got to be 370 minus 60 plus 20 plus 80. Right? So that's taking off 160, so that's got to be 210. So that's how many use just public transit. Okay. 44 students cycle or use public transit. So cycle or use public transit. So everything in the public transit circle and everything in the cycle circle has to add up to 444. So we're going to go 210 plus 80 plus 20 plus 60 plus 15. Okay, and that gives us 210, 290, 310, 370, 385. So that's 385. And it needed to be 445 minus 385, which gives us 60. So that's what goes up in here. 60 only cycle. And 265 students walk or cycle. So walk or cycle. So then this one in here, this section here, is going to have to be 265 minus everything in the walk, so 60 plus 20 plus 15, plus everything in the cycle added together, so plus 80 plus 60, okay, which gives us 265 minus 80, 95, 175, 235, which equals 30. Okay, so that's where the 30 goes, right in there, like that. Okay, so then the question that we were asked to answer was, how many students use green transportation for traveling to and from school? So we just want to add it all up, right? So we're wanting to come up with this number here. So that's going to be 210 plus 80 plus 60 plus 60 plus 20 plus 15 plus 30. Right? There should be 1, 2, 3, 4, 7 numbers I'm adding. So that looks good. Okay. So we should get 475. So 290, 350, 410, 430, 440, 450, 460, yep, 475. Okay, so that works. Okay, so where her mistake was she just didn't account for the one in the middle, right? She didn't actually subtract off everything in the middle. Okay. And how many students used exactly one method of green transportation? So that's walked, or just cycled, or just used public transit. And that answer you're going to get is 300 if you want to work on that one. Okay. All right, guys, that's it. Your assignment is, I've got a worksheet for you that Miss Newbigging will hand out for you, and there's some text questions as well. This is the one that you really want to spend some time on because these are the kind of the trickier ones to do. So in your textbook, page 51 to 52, numbers 4 to 9. This pen is driving me nuts. I don't know what happened to it. It's just not working. Okay, so numbers 4 to 9 in the textbook, and the worksheet you're going to do question numbers 1 to 9. Perfect. Have a good day, guys. I'll see you tomorrow.